pleasure to be.
So first, thank Julia for hosting this. She usually has really good ancillary events, so I think we're maybe an oddball in the schedule. In that I think we have a lot to bring to the table because of the esoteric work of some of our researchers at the center, at least to data security. But there's some really strong historical analogs that our team thought were relevant to the discussions we're having with AI. I work at a climate center, and one of the big things I have to do is debunk this information. I've been doing that now for years. Laura's had to do the same thing with some conspiracy theories in the polar community. And then Michael and I have been talking about some educational work, so that's what brought this team together.
Yeah.
So for introductions, Jason Cervenec, I lead the education outreach team with the Byrd Polar and Climate Research Center.
I'm Laura Kissel. I'm the Polar Curator for the Byrd Polar and Climate Research Center. I'm actually a librarian, so I get the best of both of these worlds. University libraries and Byrd Center.
Yeah, I'm Michael Flierl, Associate Professor and Student Learning Librarian and University Library.
Okay, so we've heard some talks previously that actually slide really nicely into this idea of provenance. When we talk about data provenance, it's not a new idea at all. We're thinking of it today in terms of AI and cybersecurity, but actually in the world of historical research, we've been dealing with the idea of provenance forever. And it can be thought of as a combination of these two concepts, really. The place of origin or earliest known history of something combined with a record of ownership of a work of art or an antique or an image or a document, et cetera, used as a guide to authenticity or quality or reliability. So this is my historical example, Dr. Frederick Cook and the Fake Peak. In 1906, Frederick Cook said that he was the first to summit Mount McKinley, and he published a picture on this side of the screen as his evidence of that, 1906. But in actuality, this is the picture he actually took, and he cropped the sides of that picture because that uncropped version actually showed he was not at the summit of Mount McKinley. So when we think about provenance and the implications, it is all intertwined with the ideas of trust and reliability of evidence. Once this information came out about Dr. Cook, everything he did before and everything he did after was subject to scrutiny, and he lost all the trust that he had with the public.
And also, I think there's social implications within society as well, because there's two groups that spun up to defend or refute Cook in modern American society that ended up pitting communities against each other as a result of that. So this idea of exploration and academic work would then spin off and to have an impact in the community. The Byrd Center deals with a lot of other data sets. This is actually from Laura's collection. All the three examples I'll give today are all polar in nature. These are the logs from the Byrd expeditions, 1930s expeditions, establishing a base called Little America. Unbeknownst to his team at the time, Byrd decided to then set off on his own and set up a camp about 120 miles distant from the rest of the community. He kept really good record logs that our researchers at the center have subsequently used to analyze historic events happening in Antarctica and really dial in models for climate and weather. You need these historical data sets in order to see if your modern computer analogs are operating correctly. One of the challenges with that is, and anybody who's worked with sensor data before, I also work with the state climate office, so we have to install weather stations. We're building a new network now, is you always log metadata, because oftentimes later on you have to correct for factors. We think about thermometers being around forever. They're a relatively new invention. We've only had thermometers around for about 150 years, widely available. And a lot of times you have to go in and dial in corrections for stuff that are older pieces of equipment. One of the other phenomenon is we know that Byrd during this time was suffering from carbon monoxide poisoning and having to make a decision either to dial down his generator and freeze to death or ramp it up and have sufficient heat, but probably potentially kill himself. We do have that logged here, so we do know that it's something. in contemporary times, you have to figure out what to do with that data when you go and use historical information. You try to look at the metadata and say, what was his method? Where was the instrument installed? What kind of equipment was he using? And then also, what was his mental fitness that he was using to make that decision in order to know how well you can trust it. He did keep other records, so that helped us kind of piece things together. Another is my team itself is an outreach team. We weren't really expecting to have to start logging data, but we started sending out GoPro cameras about 12 years ago. We have a media person who's part-time on staff. This is really for educating the public and our educational work. We started collecting 360 video and started to realize a lot of the stuff we're videotaping will not exist in nature shortly. Like our teams have ice cores from Africa. There will be no ice. There are no ice cores retrievable from Africa in place any longer. So the only place you can find that ice is actually in freezers on the West Campus. We're also sitting on video that probably nobody else will ever have pictures of what these landscapes look like. So then you start to think about what's the ramifications for that. If you're storing it, you want to store it, have it backed up really well. You want to make sure somebody isn't nefariously inserting information into your collection that really wasn't taken in those places. We do have people get a hold of us every now and then that think the earth is flat and want to debunk the fact that anybody's been to Antarctica. We can go through whole arguments about how I can provide sufficient evidence and how if you're pulled into that conspiracy theory, there's not a lot I can do to resolve that argument you had on a Thursday night, on a Friday morning with your friend who's really far down that rabbit hole. But how do we log data? How do we try to provide some metadata? Realizing this is not really a core funded mission we have. This is kind of a secondary thing. We do already start to use some of these photographs. People just really shot off the top. Sometimes on slides, our Polar Archive has a media select. And this is done because when you get a rock sample, we do house the US Polar Rock Repository. I'll pass the sample around. This is actually a volcanic bomb from Erebus, which is the most southern volcano in the world. I'll talk a bit about it in a second, but we have photographs that people shot. And when you get a sample from the collection, you really want to know what the landscape looked like. So we often want to know the notes that were taken in the field. We definitely have to know the GPS coordinates. If you have photographs and sketches, that's even better. So we have photographs taken from the field. The team was really insightful when they set up their database to log a lot of additional metadata to try to answer questions that might come up in the future. What I did is I actually found one of these of Nunatak. So Nunatak is a mountain that extends above an ice sheet. These are features that are pretty distinct in Antarctica. They're geologic features you can land a plane at or go to and grab a rock sample. But I asked an AI tool just to create an image of a Nunatak in a 1980s style, shot by a camera, 35mm camera from Antarctica, specifically the Taylor Nunatak. I got one of these is a true image, one is not a true image. When we talk about the definition of a Nunatak, it's pretty easy to see which one is wrong because it's a mountain that extends above an ice sheet, and there's clearly no ice sheet that the right image is extending above. It's interesting to see how these tools don't do particularly well because there's not robust data sets, pictures from Antarctica that are crawlable right now. But all of a sudden, the trust in our institution matters a lot because we have pictures we're sitting on of landscapes that are not going to be photographable in the future. And we want to make sure we know who took the image, what it was taken with, time period it was taken, ideally the perspective it was taken from or the direction it was taken from, and who did it. And this is a case where clearly the AI tool fell apart. I can actually give you, this is an example of what the data looks like. It was a photograph, we know the location, Antarctica, the location Antarctica, coordinates, time period. We can even cite where this is established from, but also in this case, the donor, collector, photographer are all the same in the method. So Andrew knows the director of our rock repository. She photographed it, was also lead expedition leader, and then was the one who ended up turning it over to the collection. I'll give you one other example, which is the one you see coming to you right now, a tangible object. So this is our searchable database. It includes both media, but also 62,000 rock samples. This is the US only collection of polar samples. So anybody who is funded, their materials go into the collection. Anybody else in the US can then use those items at no cost to analyze. The sample you see there is from that collection. But looking at just provenance, authenticity, trust, consent, the volcanic bomb you have, if I look at the file from that sample, you kind of see all the information that's provided here. We know it's a volcanic bomb. We know the location and coordinates, the time period. But we also start to identify what the peer review publication or who is the person who actually established the time period it was from, what it was from, when it was collected. The sample you see is particularly unique. They said it was a helicopter logistics and foot traverse. We actually know the exact time period that sample you have was deposited. The volcanic bomb. Somebody actually saw that crash near their tent site coming out of a volcano. And so it's a little unique. That's not typical. So if we look at this file in greater detail, we can see some of the details about that, also who collected and donated it. And then these are the time logs of when those samples fell. This is critical though, because if somebody's going to go back and use this later on and say, well, you said this was something from the Holocene. Well, what's your documentation of that? Okay, we have a log of this. Well, who collected it? Were they seen as trustworthy? Did they have some issue with scientific publications getting retracted? But you can start to track down every step of where the information came from, who was responsible for it, and how they identified if it was factually peer-reviewed or not. One other thing that I won't talk about too much because it doesn't really apply to Antarctica, so we discussed kind of provenance and authenticity, trust in both our institution and collection, but also the people that are getting us the data and doing the samples. There's a lot of trust built into the system here. Is consent. In polar regions, we don't have to worry about this too much because there's no indigenous communities or tribal government claims there because there's the Antarctic Treaty. If you are doing work, are other communities doing the work in the Arctic? This is a much more touchy issue, especially in contemporary times, because there are territorial claims there, and there's permissions for indigenous communities if you're collecting samples, and in some cases, responsibility to repatriate those materials because they actually have religious significance. Does not apply in this case because the work we're doing, it actually challenges our work. If we're being challenged to expand to the Arctic, but that means the complexity of our data sets is going to be, we have more things we have to think about. Michael?
Okay, so I think the last presenter said AI is or generative AI is the low-hanging fruit. I'm Mr. Low-hanging fruit. I'm here to convert all of this, what was previously talked about, to generative AI. So, right, so has anyone heard of small language models, SLMs? So that's becoming more and more ubiquitous. I'm getting undergraduates now who talk to me about this. OpenAI just came out with Swarm, great branding, by the way, to get autonomous agents to work together. And just today, it was Claude, what was it, computer? Or did anyone see this today? It just came out. Sorry, Anthropic, thank you. Computer use. So developers can direct Claude to use computers the way people do by looking at a screen, moving a cursor, clicking buttons, typing text. So now you're getting generative AI solutions or technology able to do basically anything a human can do at a keyboard, or you can direct use. I think that's all evidence of generative AI technology becoming more ubiquitous, smaller, it's cheaper, the price is continuously driving down. This is the world we're going to live in. And there's a whole host of interesting kind of challenges as a result. And I bring up this chain link analogy because there's documented instances of problems or issues with data that is used to train these models. So containing child sexual abuse materials, leaking personally identifiable information. And I don't know if anyone, is there an election soon? I think I heard it on the radio, right? So there's already been documented cases of deepfake videos, deepfake audio in elections in Slovakia, Argentina, Canada, US. I saw in Canada, mayoral race for Toronto, they inserted a generated image of a homelessness in Canada to drive home the homelessness issue in Toronto, which apparently is a pretty subject to attack a political opponent. Now, on a big screen, you probably could have told the difference. But on your phone, I couldn't tell if it was AI generated. So we're going to be generating, we're already starting to live in a world in which it may become harder to differentiate AI generated text, image, audio from the real thing. Notebook LM, has anyone tried that out? So I made a podcast recently of some notes I took. And then the next morning I listened to an NPR podcast. And I had this strange experience where it sounded like an AI. I don't think I realized NPR was that formulaic. but there's a whole host of issues now. So AI is going to become more ubiquitous, more important. I mean, is generative AI going to become less important in the next 5 years? Does anyone believe that, right? Probably not. So it's smaller, it's cheaper, it's more embedded. Now I have a text messaging app. My text messaging app doesn't recommend the next word. It recommends an entire message to send back, right? That's on my phone now. I didn't even ask for it. I think it came in an update. So there's all these downstream effects. Generative AI is here. It's going to become more important, but there's also issues, challenges, problems with the data that is being used to train these models. So then we have a question of how do we build a trustworthy kind of AI ecosystem or culture or society, right? So if we're going to be using AI in medicine, in the workplace, in providing government information, et cetera, you know, how can we trust this chain of data leading up to the AI output? The models themselves are one thing, but right now, currently, it's quite opaque where the data is coming from and can we trust the data that is being used to train these models. So there's a whole host of issues. Someone brought up the EU AI Act. You know, President Biden has an executive order. The Canadian government, UN bodies have all, in one shape, form, or another, tried to get at this issue of data transparency, data provenance. Where is the data coming from that is being used to train these models, and how much can we understand about it? Is there hidden bias in this data? The answer is likely yes. In plenty of instances, facial recognition technology tends to be far worse at darker colored skin tones than other skin tones, which leads to issues, right? And there's a whole host of issues, especially, I'll point out this middle one. I'll show you a patchwork of possible solutions in the next slide, but currently the problem is they're all kind of just a patchwork. There's no one unified or singular system or approach. Imagine for the rock sample that was passed around. By the way, don't open that bag. Jason told me to cut the hell out of your hands.
I should tell you, it's glass.
Yeah. Yeah. Jason told me that right away.
Hopefully.
I was looking around making sure.
Yeah.
Right. But imagine if there were 5 different metadata sets of giving differing opinions on where that rock came from and why it was important, right? Would the climate change denialists have a field day? Probably. That's an issue if there's a set of multiple standards. A single unifying framework is not only desirable, but I think necessary to solve some of these problems. And so that's going to require, sorry, one more thing on this slide. That's going to require a whole host of different stakeholders coming together. That's private business, that's government, that's researchers. If researchers have one set of standards, government has another, and if we can't talk to each other, that could lead to some issues of trusting some AI, but not trusting. And so this comes from a paper, you'll see the citation later, from researchers from MIT and Harvard. I'll point out a few of the current kind of patchwork solutions or approaches to this. So one is content authenticity. You'll see here at the top. That's trying to embed metadata into training data to try to describe what it is and to say that, yes, this is authentic data, this has been tested, it's verified, et cetera, but as you can see, it's of limited use, or it's not being used particularly widely. And, oops, I lost my notes. Our students always make fun of me for not having my cell phone, but okay. It doesn't cover privacy though. So it might dictate that, yes, this is a legitimate data set or where it came from, but it doesn't describe, does it violate certain privacy standards? Robots.txt, this is a common text document in a website saying you can, search engines, you can call this part of a website, but you can't call this part. Well, a lot of AI companies have just kind of blown past this and they'll still crawl sites that web developers say, please don't crawl. Data documentation, like data standards. So there's certain things like a nutrition label you might see on like archive.org to where for a data set, it'll look like a nutrition label. This is where this data comes from. This is X and Y and Z, and this kind of describes the data. But there's a problem in having like an individual kind of nutrition label for data for all the different data sets available. So some are very wide, from Hugging Face, which is kind of a GitHub repository for AI data and models, but that tends to be crowdsourced and not very accurate. And then you have much more accurate data documentation, but it's not very widespread. And so functionally, you have a wide swath of different potential approaches at this issue, but we don't have a singular framework or approach, which is an issue compared to what we have even just for like polar research, for instance. So I'm going to leave it to Laura to finish this off.
So Michael created this excellent scaling Mount AI graphic to kind of circle back to our first little slide with Dr. Cook. What comes to mind when we talk about all this for me is, what does evidence look like in 2024 versus 1906? Is it harder to evaluate the evidence today than it was in 1906, or is it easier? You know, today when I climb the mountain, I've got my cell phone and it marks my, you know, I drop a pin and I got GPS and I got my coordinates and I got all my things. In 1906, I have my book, write it down. I take maybe 3 pictures because I'm carrying this heavy ass camera without much, you know, in the way of equipment. And maybe I have one witness, me, maybe. But in the world we live in today, we have so much more coming in. I think it asks really interesting questions about how we evaluate provenance, authenticity, trust. How do we decide? How do we teach people to look at what they're, you know, how to be critical about what information they're getting?
So all this seems like a new challenge, but remember, a lot of the stuff Laura's dealing with and I'm dealing with is quite old. There might be historical analogs to teach us how to deal with this. This is not the first time we've confronted it. AI is just another tool, and a lot of times we've had to address these in prior circumstances. Questions?
Thank you.
Thank you.
Thanks.
Here's your also the you bring the collecting lot pieces of data on. There's more data.
I think you want to know that, I mean, ideally you want to know what it is and where it comes from. So logging who took the picture, who they passed it to, who inevitably donated it, or, for example, the peer review publication that says, well, this is the mineralogy of it. You can trace back and look at the author and say, oh, they're an expert in mineralogy, like they're qualified to say this, versus a publication where somebody's maybe off their main research area. So not only knowing what's been said, but tracing it down to, well, what's the source that came from. So we're finding out the database we have is really robust, but we're adding more and more fields. Even when we add samples, we have primary accession numbers and secondary. There's numbers we assign, but also we have some samples that come in from researchers, and the numbers are all lined up in the book, and every sample's there. And we get other ones, it's a bit of a hot mess when it comes in. And they change their labeling system halfway throughout, and the person we're logging and doing the best we can, but they've died. And so the person who collected it and donated it. So we now have to interpolate, and if there's some question of it, that's all noted, and then there's a secondary numbering system to say, we might have got it wrong, and that might not be found out till later on, but at least you know we did the best we could in a certain situation. Now, how do you not lose that when you ingest that into some tool and then you can't pull it out later on? That's kind of the hazard we're explaining here. Better to know that or have a later thought.
Do you see the problem then, or maybe the metadata behind some of the information taking more of a role in the AI model, so that maybe with additional metadata, additional kind of sources or corroborating it, then becomes a little bit more aligned with what we pulled out. Google generate a picture in Gemini, that gets put into an AI, into a large language model. That might now become the source of what is true, right?
Yes.
because that metadata, the source of information, et cetera, starting to play more of a role in what becomes the basis for truth in the large language model framework.
I mean, that's one thing, as you can say, you should weigh it more heavily, because we're a trusted institution, does fuller research, and at least if we have that standing, something from our collection should weigh more heavily. We talked also about feedback cycles. If this is feeding back on itself to getting used and then ingesting into a model again, like feedback on a microphone, what is that? We just discussed that, and then we don't really know what that looks like. But then that can take you and start to introduce bias. So these are all issues we think about because of the questions we get from the public or researchers. And we're sitting on collections now where maybe it's not an issue now. But even in Laura's collection, you could go to the archives. One of the things they're always worried about is you can't have a pen, right? You can't
have a pen.
adulterate documents. We don't want you taking stuff out, but what if you start slipping stuff into the files?
Right.
Like, that's a hazard now. We want to kind of protect our collection to say, I know what's in there. We didn't set it up that way. But now all of a sudden, this is going to be critical polar data, weather data from the state. We have instruments now collecting data. Introducing data can be as bad as taking something away or adulterating.
It's been two things. Recently gave a lecture to like 20 or so undergraduates about generative AI, and only like 2 or 3 of them heard about hallucinations. They did not understand the difference between an AI generated text output and something you found on Google. They basically equivocated between the two. That's a problem for an educator. And then 2, imagine the world, imagine internet in a couple of years. It's 80% AI generated. And there are very serious scholars and researchers who think that's going to be the case. It could be, maybe shorter time frame, longer. And I mean text, audio, every YouTube video, 80% chance AI generated. Right? So what is going to be the value, or how much can you trust a public institution like Ohio State? So you can find an undergraduate says, I found this online, versus I found this in the Polar Archive. What's the difference? I want to write on the language. So the amount of trust we put in public institutions is potentially going to change radically if the internet changes. And I've heard of something called model collapse. With generative AI, the internet is so imbued with AI generated content. There's no, truth grounding of factual content that trains the next generation of AI. And so it kind of becomes at a rebus and needs to fail. That's a possibility.
Oh, that uplifting note.
Yeah. Oh, you haven't, I think you heard of synthetic data? That's so much fun. AI output trains the next AI. Yeah.
We'll mention one thing too. If anybody's thought about the value of those of us that are sitting in institutions, sifting fact and fiction, and sitting on collections that help. I know if anybody else has read the book Constitution of Knowledge in here, highly recommend it. Historian and philosopher at Harvard that really looks at the value of institutions like universities, libraries, data storage facilities, like how we sift fact from fiction in a complex world. It's a thick read, but it just live. A lot of us have responsibility that those institutions and really be held to high standards. That book explains why that's important for the general public and how we operate in society.
I have a question related to that, because if you have a standard set of metadata, somebody's coming up with that can be used as a forensic tool to help you identify what's real and maybe what's synthetic. Is anybody working on that, putting together something like that?
I don't know. I mean, that paper.
Yeah, for generative AI or AI applications.
Yeah,
broadly.
For both, actually, for everything. I mean, if you have a standard set of metadata that gets applied to all data that you're working with, or it needs to be available, if it's not there, then it kind of leads you to believe that it may not be a truthful product.
Right. So like libraries have stuff like DLC, machine readable cataloging, that are standard metadata fields that are applied to each individual item or object or collection. So that happens. AI data, data in which AI is trained on, as far as I know, is generally speaking the Wild Wild West. There's some elements, there's some of those like patchwork, different entities are coming at it from different perspectives, but there's no singular approach or framework that would cover this across the board. That's what that, whole article is position paper saying, that's a problem, we need to do that. For